In lesson 4.8, you will use the quadratic formula and the discriminant. Here we're going to complete the square on standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. So our first step is to make sure that our a value, or our value multiplied to x squared, is 1. So we're going to divide every term by a. So I get 1x squared plus b over a x plus c over a equals 0. But I know that I have to move that constant term to the other side of the equation, so I'm going to and leave a space to complete the square on x. So I'll write this as equals negative c over a. And now I'll take my b value, which is b over a, my value that's multiplied to x. I'll divide it by 2 and square it to complete the square on x. Dividing by 2 is the same as multiplying by 1/2, so I have b over 2a squared. And squaring the top, I get b squared. Squaring the bottom, I get 4a squared. This is the value that I'm going to add to both sides of this equation. B squared over 4a squared. Okay, and now I want to factor on the left. Factor that perfect square trinomial into a binomial squared. Take the square root of the first term, the sine of the middle term, and the square root of the third term. Square root of the top is b, and the square root of the bottom is 2a. Okay, on the right-hand side, I need a common denominator in order to add these two fractions, and that common denominator is going to be 4a squared. So I'm going to multiply this first fraction by a form of 1, 4a over itself, so that I get a common denominator. Okay, and now on the right-hand side, simplifying, adding my numerators and putting them over my common denominator, I get negative 4ac plus b squared over the common denominator of 4a squared. Now I'm ready to take the square root of both sides. So when I take the square root of this binomial squared, I get x plus b over 2a. That gives me two solutions, plus or minus, and I'm going to start simplifying on the right-hand side here. I've got the square root of b squared minus 4ac. I'll just commute those two terms in the numerator and take the square root of the denominator. The square root of 4 is 2, and the square root of a squared is a. And now to get x alone, I'll just subtract b over 2a from both sides of this equation. And since I have a common denominator on the right-hand side, common denominator of 2a, I'm going to add my numerators and put them over that common denominator. So I'm going to get b squared, negative b, plus or minus the square root of b squared minus 4ac, all over 2a. And you might recognize this as the quadratic formula. We've just derived the quadratic formula by completing the square on standard form. The quadratic formula can be used to solve any quadratic equation. And we're going to use it to solve these two quadratic equations. The first thing we need to do is get our quadratic equation in standard form. 0 on one side. So in this one I'm going to subtract 35 from both sides to get 0 on the right. Then I see my a value is 3, my b value is 8, and my c value is negative 35. So in the quadratic formula, I'll substitute in 8 for b, and in for a, I'm going to substitute 3, in for c, negative 35. All over 2a, and a is 3. Okay, simplifying in the top, I have negative 8 plus or minus. Underneath this radical, I have two products. I have 8 squared, which is 64, and then I'm going to get a positive product here, 12 times 35, and I'll just use my calculator to get that value, 420. And in the denominator, 2 times 3 is 6. Okay, so I'm getting negative 8 plus or minus the square root of that sum underneath the radical is 484. And if I run that through my calculator, I find that 484 is a perfect square. So I'm going to get negative 8 plus or minus the square root of 484 is 22. And now I can find my two solutions. One is negative 8 plus 22 over 6, and the other solution is negative 8 minus 22 over 6. So x is equal to 14 over 6, and that simplifies to 7 over 3, getting rid of a factor of 2 top and bottom, or negative 30 over 6, which is negative 5. Okay, in the second example, let's get 0 alone on the left by adding 2x squared to both sides of this equation, and then picking out a, which is 2, b, which is negative 2, and c, which is 3, I can substitute into the quadratic formula. Negative 2 for b, and in for a, 2, in for c, 3, all over 2a, or 2 times 2. So minus minus 2, that's positive 2, plus or minus the square root of my two products underneath this radical. Negative 2 squared is 4, and I'm going to get negative 24 when I multiply, and 4 in the denominator. Okay, so now I have 2 plus or minus the square root of negative 20. So I see that my solutions are imaginary, and I need to simplify. So underneath that radical, I'm going to factor negative 20 into negative 1 times the perfect square factor is 4. And then simplifying, underneath that radical, I have 2 plus or minus the square root of 4 is 2, the square root of negative 1 is I, and I'm left with the square root of 5. Now that's all over 4, but I need to leave my imaginary solutions in a plus bi form, so I'm going to divide both terms by 4. So I'm going to find out that x is equal to 1/2 plus or minus 2's will cancel, so I have I square roots of 5 over 2. Okay, here we're going to use the discriminant, and the discriminant for a quadratic equation is b squared minus 4ac. That's found underneath the radical in the quadratic formula. If the discriminant is 0, we know the quadratic equation has one real solution. If it's positive, the equation has two real solutions, and if it's negative, the quadratic equation has two imaginary solutions. So let's look at the first example. We're supposed to find the discriminant and describe the solutions for the quadratic equation. So my a value is 9, my b value is 6, and my c value is 1. So b squared is 6 squared minus 4 times a, which is 9, times c, which is 1. Would simplify to 36 minus 36, or 0. The discriminant is 0, which tells me there's one real solution to this quadratic equation. Okay, in the next one, our a value is 9, b value 6, and c value negative 4. So b squared minus 4 times a times c would look like this. And simplifying, we get 36. This is a positive product. And 16 times 9, using my calculator, is 144. So adding, I see that I'm going to get a positive value of 180 as a discriminant, which tells me there's two real solutions to this quadratic equation. And the next one we need to get in standard form. So I'm going to add that 5 to both sides, leaving 0 on the right. My a value is 9, my b value is 6, and my c value is 5. So I'm going to have b squared minus 4ac to simplify, which is 36. I'm going to get a negative product here, 20 times 9, 180. So I have more negatives than positives. My discriminant is negative 144, which tells me there's two imaginary solutions to this equation. Okay, we're going to run out of time, so we're going to skip example 4. You might want to try that on your own. And we'll look at this last example. A man tosses a penny up into the air above a 100-foot deep well with a velocity of 5 feet per second. The penny leaves the man's hand at a height of 4 feet. How long will it take the penny to reach the bottom of the well? We've already looked at the falling object model, but this problem requires the vertical motion model, which is h equals negative 16t squared plus vt plus s, where h is the height of the launched object in feet after t seconds, v is the initial vertical velocity in feet per second at which the object is launched or thrown, and s is the object's initial height in feet. So we want to write this equation. We want to know how long it will take the penny to reach the bottom of the well. So that height that we're talking about when this penny stops is going to be negative 100. It's at the bottom of the well. We're going to solve for t, for time. We're looking for how long it takes that penny to reach the bottom of the well. The initial vertical velocity is 5 feet per second, so we'll put that in for v. We're going to solve for t again, and in for s, the initial height is 4. It left the man's hand at a height of 4 feet. Okay, so we need 0 on one side of this equation, and we're going to use the quadratic formula to solve for t. So I'm adding 100 to both sides of this equation, so I'm going to get 104 on the right. Okay, now I can pick out my a value, which is negative 16, my b value, which is 5, and my c value, which is 104. So in the quadratic formula, t is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now if I run this through my calculator, I'm going to find out that t is approximately negative 2.40 if I run it through with a positive sign, and if I run it through with a negative sign, I'm going to get positive 2.71. So I know that time in this problem cannot be negative, so I'll choose the positive value for my solution, and that penny is going to reach the bottom of the well in 2.71 seconds. Include with your notes of this video guided practice problems 1 through 9 odd, found on pages 293 and 294 of your textbook.